Okay, so this is problem 24, chapter 9 of Giancoli 6th edition. So we have two trees, and we know the distance between them, and we have a backpacker who is trying to lift his pack out of the reach of bears. Okay, so the drawing is more or less like this. We have one tree here. Okay, we have another tree there. We know the distance between these two trees. It's given to us. Okay, so I'll call this distance L. And we have this man down here exerting a force, so on a rope. So here there is a pulley, he's exerting this force, and here we have the rope. This rope is sagging right in the midpoint and holding this backpack. Okay, so we also have the weight of this backpack is also given to us. And what else they give us? They give us by how much this backpack is sagging. Okay, right in the midpoint. So it's not in a horizontal line, it's sagging by this amount, which I'm going to call h. Okay, so since this is right in the midpoint, I also know that this distance here is L over 2, and this one also L over 2. Okay, so the force that the man exerts here, the force of the man, is just equal to the force, the tension force, along this side of the rope. The other side of the rope is again the same tension force and is being held by the tree here. Okay, very well. So how are we going to solve this problem? Okay, so these two tension forces are the same. We see that there is an angle here with the horizontal because the rope is not perfectly horizontal. So I'm going to call this angle here theta. Again here theta. And you see that theta is also here, is also here. So we do know theta because this triangle here, we know these two sides. It's a right triangle and we know these two sides. So I know that tangent of theta is equal to the opposite divided by the adjacent. So from here we can find this angle. All right, what else do we have? We have that the sum of the forces in the y direction have to be 0. So what are the forces? Let me use this reference frame. So what are the forces? I have Ft sine of theta plus Ft sine of theta. No, there are two tension forces minus mg equals to 0. And that's it. Because now with the angle, we can find Ft, and Ft is equal to the force that the man is applying.